All right, thanks for that question. In the box there, I think I have written down what you typed out for your original question. It was a little bit hard to tell with the formatting. So if that's not the original question, then you can disregard the video or just kind of follow along, because it could kind of also probably help answer your question if it's a little bit different. So you're going to need 3 tests. Normally these problems where you're looking for convergence, you're looking for the values of x that will help this series converge. So what we're going to do usually to begin this is called the ratio test, where you put you put a subsequent term. In other words, you change n's to n plus 1 over the current term, which is when it's the original formula right there. So to save space here, what I have is I have the next term in parentheses right there. And instead of putting it over the current term, I'm going to flip over the current term just to save space and multiply. Since the definition of division is just multiply by the reciprocal. Now we're going to take the limit as n goes to infinity. So don't worry about the x's yet, just the n's. Because the degree of n is to the 1/2 on both of these, and n is going to infinity, equal degrees will just cancel out. So you get rid of those 2 parts. And then for the negative 3x part, since they have the same base on the top and bottom, you can feel free to subtract the exponents, which winds up being negative 3x to the first. For the ratio test to converge, it has to be between negative 1 and 1. So as we solve that inequality, dividing by negative 3 makes you have to flip the signs. And this is what you get when you flip the signs. That's negative right there. Now, at the end of the ratio test, you need to test those 2 endpoints to see if they are included in the interval of convergence. So when I plug in negative 1/3, the smaller number, back into the original function in the box, when I plug in negative 1/3 for x, I get negative 3 times negative 1/3 is 1. I'm basically going to change the bottom to just be n to the 1/2. It is still radical n plus 2, but that doesn't matter. The fact is it's n to the 1/2. Now, if that exponent on the bottom is less than 1, by p-series, you will diverge. That's the p-series test. So negative 1/3 is not going to be in our interval. When I plug in positive 1/3, it makes the base on the top negative 1. And since the degree on the bottom is higher than the top, this will decrease as a function. And since it alternates with the negative 1 on the top by alternating series, that now converges. So even though the one in, let's see if I could change the color here. I'll just put it in a box. So even though this one decreases, it diverges because of the exponent on the bottom being less than 1. But as soon as it alternates, that one in the second box converges. So we're going to use this number in our radius of convergence. So the radius of convergence is negative 1/3 to 1/3, with only negative 1/3 being in the interval. Hope that helps.